All right, so when we look at this section, we're looking at solving radical equations, and you might say, well, how does this come into play? And so the thing is about these guys is that these are actually radicals. They're radical equations written in exponential form. So let's go back just real quickly and review something here to make sure we understand. Getting a little bit of lag, sorry about that. And so here, what I want you to see is that this right here would be called rational form, and that you have it's in rational exponent form, and then this would be in radical form because obviously you can see it has a radical on it. The point of this lesson is that this number down here on the bottom is your root, just like the B right there, not your boot, is your root. And this number right here is your power. And being like that, your A is your power. So, for example, some very basic ones that you've been doing your whole entire life would be is that the square root of 4. Well, there's an understood 2 right there, and there's an understood 1 right there. This is your root, that's your power. The power goes in the numerator, the root goes in your denominator. And so you can always solve problems like that. So, as we move forward, and we're taking a look at these guys, even though the technique that I'm about to show you doesn't utilize that, I want you to understand that's why this is working, because we're undoing the roots and the powers using inverse operations. So when I say to you, for example, on this first one, I say that I have x to the 3 halves, you know that the 3 is your power and the 2 is your root. And so to be able to undo that, you would have to do the inverse of that. You'd have to do the opposite of that. So like for example, if this was written out as a actual in radical form, this would be x with a radical on it. There'd be a 2 right here, and there'd be a 3 right here. So if I wanted to undo the third power, I would have to take the third root of the entire thing. So the third power and the third root would cancel each other. If I wanted to get rid of the square root, I'd have to take this guy and I'd have to square the entire thing. So the square root and the square would cancel, and we would be left with just plain old x. Well, that's what we're doing. When we solve this problem right now, and we come across it, and we want to be able to find x, this guy is equal to 8, we're going to take this guy, and we're going to raise him to the 2/3 power. Because our radical, our root would be 3, our power would be equal to 2. If we do something to one side, we have to do the same thing to the other side. So the beauty of this is that now we have these two fractions right here that are going to undo each other. They're going to turn into a 1 because we have a 2 on the bottom, a 2 on top, a 3 on the top, and 3 on the bottom. So on that side right there, we're left with just plain old x, or x to the first power, however you want to think about it. Equals, we take our calculator, and we take 8 and we raise it to the, and you can use your fraction bar if you want, we raise it to the 2/3 power, and the answer is 4. So the property that we're really doing in the back side of this is this whole idea of inverse operations with radicals, undoing using radicals like we've been doing so far in this lesson. But we're in rational exponent form, so we can use the reciprocal to be able to solve it. So on the next guy, same deal. We've got x to the 5/2 is equal to 32. I raise this thing to the 2/5 power. Whatever I do to one side, I have to do to the other side. In this case, the 5 cancels, the 2's cancel. I'm left with x equals, I pull out my calculator, and I'll show you a slightly different way to type it in, 32 raised to the, and you can just do 2 divided by 5 if you have a TI-84. And it'll punch it out there real nice, and you get 4. Now, just make sure you realize the answer is not always 4. Alright, so let's apply that now to when we actually have an equation. So, same deal, we want to get to these x's right here. We need to get inside of this to be able to solve this equation, but we have this 1/5. So we need to get rid of that 1/5, 78x. We need to get rid of that 1/5 power. Well, that's not a problem because we know now that we can just take this entire thing And we can raise it to the 5 over 1, or the reciprocal power. Whatever you did one side, you have to do to the other side. On the left-hand side, the 1's go away, the 5's cancel each other out, and we're left with x squared plus 78x is equal to, and we take our calculator out, and we say 3 raised to the, and it's really just the 5th power, but if it makes you happy, you can put 5 over 1, and so we get 243. At this point, you say to yourself, okay, well, that looks like a quadratic because I have a degree of 2. If I have a degree of 2, I move everything to one side, so I subtract 243. I subtract 243. And now I'm back to what we've been doing, and what we will be doing throughout the rest of this class, and that is factoring. So you look at that guy and say, can I factor that? Well, let's see. My product, my sum, my factor. My product is negative 243. My sum is positive 78. I take my calculator, put that back underneath. I take my calculator. I go to y equals. I say 243 divided by x. I go to my table. Second table. I go down. I'm looking for two numbers that add up to 78. Well, if I add those, I get 84. If I subtract them, I get 78. So I've got positive 81 and negative 3. I come over here. I say x plus 81, x minus 3. Remember at this point, that's set equal to 0. We take each one of those and set them equal to 0. So this is x plus 81 is equal to 0, x minus 3 is equal to 0. These guys right here are called factors. What we're about to do right now is called a solution. We solve each one of these. We get x is equal to negative 81 and x is equal to positive 3. Now, technically, because this is underneath a radical, we need the check. So technically, we need to come up here and we need to do a check. So we take that original equation right here, and we are going to check to see that what we have actually works, or if they both work, or if neither one of them works. So we do our check. So we do our check for x equals negative 81. So that would be negative 81 quantity squared plus 78 times negative 81. All of that raised to the 1/5 power should be equal to 3. So we take our calculator. Once again, I'm a big advocate. Don't go through and try to plug this all in at one time. Let's just start off with the smaller stuff. So negative 81 squared plus 78 times negative 81. So what we have right now is we have 243 raised to the 1/5 power should be equal to 3. So we take that number, we raise it to the 1/5 power, and sure enough, 3 equals 3, so check, that's good. 81 is one of my solutions. I do the same thing for x equals 3. So I've got 3 squared plus 78 times 3. All of that raised to the 1/5 power should be equal to 3. So that's, pull our calculator out, we got 3 squared plus 78 times 3. That's 243, and if you're seeing the pattern here, the 5th root of 243 is going to be equal to 3, so 3 equals 3, so sure enough, both of these guys are our solutions, negative 81 and positive 3. Alright, so that's taking care of rational equations with rational exponents.